brain-machine interface, essentially translating the neural activity of areas of the brain that would produce speech into hardware, artificial, non-biological tools, in order to allow paralyzed people to communicate.
So there are a series of conditions. They include things like brainstem stroke. The brainstem is the part of the brain that connects the cerebrum, which is the top part, does our thinking and a lot of the motor control, speech, language, everything. And the brainstem is what connects that to the spinal cord and the nerves that go out to the face and vocal tract. So if you have a stroke there, you could be thinking all the wild, creative, intelligent thoughts you have in the mind and the cerebrum, but you can't get them out into words, or you can't get them out to your hand to write them down. So that's a very severe form of paralysis called brainstem stroke. There's another kind of conditions that we call neurodegenerative, where the nerve cells die, basically, or atrophy, in a condition called ALS. That's a very severe form of paralysis. In its extreme form, people essentially lose all voluntary movement. The muscles to their diaphragm and their lungs essentially give out as well. They get weakness there, and then they can't breathe anymore. In our field, these are kind of like the most devastating things that can happen. This condition of what we call being locked in refers to this idea that you can have completely intact cognition and awareness, but have no way to express that. No voluntary movement, no ability to speak. And that is devastating because psychologically and socially, you're completely isolated. That's what we call locked-in syndrome. And it's devastating. So we've been studying this patterning of electrical activity for consonants and vowels. And essentially, once we figured out a lot of these codes for the individual phonetic elements, part of the lab started to focus on this very specific question. For people who have these kind of paralysis, could we intercept those signals from the brain, the cerebral cortex, as someone is trying to say those words? And then can we intercept them and then have them taken out of the brain through wires to a computer that are going to interpret those signals and translate them into words? So we started a clinical trial. It's called the Bravo trial. It's still underway. And the first participant in the Bravo trial was a man who had been paralyzed for 15 years. He was in a car accident. He actually walked out of the hospital the day after that car accident, but the next day had a complication related to it where he had a very large stroke in the brainstem. And that turned out to be devastating. He didn't wake up from that stroke for about a week. He was in a coma for about a week. And when he woke up from that coma, he realized that he couldn't speak or move his arms or legs. As he told me or